Let's practice some algebra. These are for sure the easier types of questions that you can expect to see on the SAT exam. So these questions are on powers and radicals. So we're going to breeze through them, hopefully be able to solve them quickly. If not, I would challenge you to figure out why you're taking so long to solve these problems. Okay? Probably just not fluent in the properties and all that. Okay, so question one. You have 9 cubed times 27 squared equals 3 to the n. What is n equal to? Okay, so hopefully you tried it yourself. The trick here is, well, there's lots of ways you can solve this, especially now that a calculator is always allowed. You could just plug in the left-hand side and then plug in different values of n for 3 to some power to get your answer. If you want to do it by hand, we write 9 as 3 squared, so 3 squared cubed. 27 is 3 cubed, so we write this whole thing as 3 cubed squared. Use properties of exponents, so you can combine these by 2 times 3. Same thing over here. And then from here, you can use the property that when you're multiplying these two, you can add the two values, the exponent values, so it's 3 to the 12, so n is equal to 12. Okay, what about this one? X to the negative 3 equals 1 over 8. X is equal to what? Okay, hopefully you got x is equal to 2. You can rewrite this as this negative exponent as 1 over x cubed. So the x cubed is 8. So if you invert both sides, so the x is 2. Okay, what about this one? 4 to the negative a equals 64. What is a equal to? I guess that's what the question was asking. Okay, well, 4 cubed is 64. So 4 to the negative of negative 3 will be 64. Next, 5 root 8 plus 7 root 32. How do we simplify this? Well, choice C is already suspicious because that's not even fully simplified. 4 times 2 is 8. We purposely want to pick 4 because 4 is 2 squared. Okay, and then 16 times 2 is 32. We purposefully want to pick 16 because 16 is 4 squared. Okay, instead of breaking up 32 as 2 times 2 times 2 times 2 times 2, 2 to the 5th, just jump to 2 to the 4th, which is 16. Okay, so you would get 38 root 2, and that is choice B. How about this one? How do we simplify this? This one is a multiplication. So what makes it different? So we can multiply the outsides first. So that's 44. Yeah. So you could already probably eliminate A and B. Those are smaller. And then 18 times 12, we can simplify to, well, let's break it up a little bit. You can directly multiply those radicals together, the insides. This is just a property, which is a property of exponents, by the way. 18 is 9 times 2. 12 is 4 times 3. Why do I want to break it up like that one? 9, if we bring out the square root, it's 3. 4, if we bring out the square root, that's 2. Okay, so then you get 264 root 6. Number 6, y to the negative 5 is 1024. What is y equal to? Okay, so especially since you're allowed a calculator, you can just exponentiate both sides to the negative 1/5 power because we're interested in y. So to get y on this left-hand side, you can exponentiate by negative 1/5 power. So minus 5 times minus 1/5, that's just 1. Okay, and then 1024 to negative 1/5 power, you can put that into your calculator. That's 1/4, which is E. 7, 2 to the minus n is 1 over 256. What is n equal to? Again, you can just put this in your calculator if you really want to. Or so you can solve it by hand, n is equal to 8. You can even do log base 2 of 256 is equal to 8. Okay, question 8. Square root of x is 4a squared bc cubed. What is x equal to? What do? We just square both sides of the equation. So the left-hand side, you're left with x. Right-hand side, we use the property where you distribute this power to each and every single term. So then you would get 16a fourth, b squared, c to the 6. Okay. How about 9? 8 to the 12 equals 2 to x. What is x equal to? We did something similar to this not long ago. You rewrite a as 2 cubed, and then use properties of exponents to combined is 3 and 12 to 36. So x is equal to 36. Question 10, c to the 2/5 power equals 4. What is c equal to? We did this trick not long ago as well. We can exponentiate both sides to the 5/2 power, so that on the left-hand side, you get c, which is what we want. And then 4 to the 5/2 power, well, we can rewrite it as square root of 4 to the 5th power. What's square root of 4? That's 2 to the 5th. That is 32. Number 11. How about this one? Okay, so again, similar technique. We can rewrite them as 3 to some power, so 3 squared to the 4x over 3 cubed to the 3x. Okay, and the properties of exponents, that's right here. And the properties of exponents, again, you subtract the powers, so you get 3 to the minus x, which is 1 over 3 to the x. That's choice B. Which of the following is equal to 5 to the 8x? Okay, let's go choice by choice. How do we simplify this guy? It would be 5 to the 4x times 4, which is 16x. That's not right. Not true. How about this one? It'll be 5 to the 4x times 2, which is 8x. Good. How about this one? Well, this one, you use the property where you add the exponents, because this is 5 to the 4x times 5 to the 4x, or you could rewrite it even as 5 to the 4x squared as like number 2, which since we said 2 is true, 3 is true as well. Okay. 13, n cubed greater than or equal to n squared for which of the following? Well, if n is equal to 1, you get 1 is greater than or equal to 1. That's true. 0 is greater than or equal to 0. That's true. And then -1 is greater than or equal to +1. That's not true. So 1 and 2 only. Number 14. This is a very typical algebra problem. How do we simplify this? You have these a's, so it'll be 2 minus -5, which is 2 plus 5. So a to the 7th we should get. Okay. B to the -6 plus 2. So we get b to the -4, which is b to the 4th on the bottom. Looks like probably this one. Yeah. Let's confirm c to the 11th divided by c to the 7th. So 11 minus 7 is 4. So c to the 4th. Yeah. D to the -4 divided by d to the 9th. That's d to the -4 minus 9. So d to the -13. D to the 13th on the bottom. Choice C. Okay. Of course, on the SAT exam, you don't have to show all this work. This is just me showing it for you to see it. If you didn't understand it, you can see how I did everything in my head. And I verbally expressed my thoughts out loud. Okay, how about this one? Hopefully you have the technique down now to solve these exponential equations. We write them as 3 to some power. So 27 is 3 cubed, 81 is 3 to the 4th. Part of these exponents, it becomes 12 over x. So 12 over x is equal to 4. X is equal to 3. 16, 3 root x minus 7 equals 5. What is x equal to? We want to isolate the square root first. So add 7 on both sides and then divide by 3 and then square both sides. So x is equal to 16. How about this radical equation over here? What is x equal to? Well, we can combine like terms first. So 9 root x minus 7 root x, that is 2 root x. So 2 root x minus 36, or we can even add this 36 to both sides first. So that's what I did. So 2 root x is 20, divided by 2. So square x is 10. Square both sides, x is equal to 100. How about this one? X is 2, y equals x squared. What is y squared minus x cubed to the x squared over 3y? All right. So this one's a little more puzzle-like. So we want to evaluate this guy. Well, we know that y is equal to x squared. So y squared is x to the 4th. We can replace this with x to the 4th. And then 3y, we can replace that with 3x squared. Okay? And then when we do that, right here, as I was saying, and then we know that since x is equal to 2, 2 to the fourth is 16, 2 cubed is 8, so I plug that in. And this simplifies to a third. Okay, we know that x is not 0, so we're good with canceling there. So it'll be 8 to the 1/3, meaning cube root of 8, which is 2. Right? That's probably the hardest one in this section. Now we have this one. Square root of x plus c times square root of y equals d square root of y. So what is x over y? Okay, so let's combine like terms first. Let's move c root y to the right-hand side. And then we can factor out the square root of y right here. Divide by square root of y. Oh, I guess I didn't do that yet. I squared both sides first. Okay, so I have here. And then divide by y on both sides. So x over y is d minus c squared. And that's it. Hopefully this was simple. These really should be simple because these are, I believe in digital SAT, this is majority or a lot of what you get in the module one, part one. And if you can't even get these easier questions, they will for sure cap you for your highest score in the second module. You have to be able to get these down accurately and quickly.